Hi, welcome to BC Video 10.5a Part 2, More Polar Area.
Okay, number 12, find the area of the interior of r equals 1 minus sine theta. Okay, so we should recognize that as a limacon. We're going to plug in 0 pi over 2 pi 3 over 2. When we do that, we actually get the pole. There are 4 intercepts, so it is a cardioid. And this is what it looks like. Now, this is a sharp turn. They want the area of the interior. So, what we're going to do here, all right, we're going to need the tangents at the pole. So we're going to take our equation, replace r by 0. We're going to get sine theta equals 1, which will happen when theta is pi over 2. And sure enough, you can see that you went from the point 1, 0 to the point 0 pi over 2. So, I have to look at this question because there's something wrong. Why am I only finding the 2 little parts here and not the whole thing? Number 12. Let me look at that. Yeah, I'm missing something here. Oh, they want you to find the interior of r equals 1 minus sine theta above the polar axis. Okay, that makes sense. Okay, I thought I wrote that in. So they only want the part above the horizontal axis. So the total area they want are these 2 green things. You cannot go from 0 to pi because there's a sharp turn in there. So you will need to split it up. You can tell these 2 are symmetric, so you'll do 2 times 0 to pi over 2. So remember, the formula is 1/2 r squared d theta, so I have 2 times 1/2. Here's my r squared d theta, and my borders, okay, so my border here, it's pretty obvious that this edge is horizontal. That is theta equals 0. Harder to tell what this one is. It's now 3:05, but we just found out that it's theta equals pi over 2. So I'm going to square that binomial. I'm going to replace sine squared, etc., etc., etc. And you will get 3 pi over 4 minus 2, which is the same thing as 3 pi minus 8 all over 4. And I wouldn't do this. I don't think you should go from 0 to pi because you're passing by. I'm actually going to take that away. I don't like that. Because you're passing by a non-differentiable location. If it's not differentiable, it's not going to be integrable. So you should... Oh, I just forgot... Oh, it's 2 times a half. The 2 and a half are already gone. That's our answer. We're good. Okay. Example, find the area bounded by r equals 8 sine theta. If you remember, that's a circle. It's symmetric with respect to the vertical axis, tangent to the horizontal axis. The diameter is 8, so the radius is 4. So geometrically, and they are asking you to do this, by the way, they're going to ask you to do it geometrically, and they're going to ask you to do it, where do they do that? I know this is somewhere, where they're going to ask you to do it geometrically as well as... Well, maybe not in your book. Okay, so geometrically it's just a circle with a radius of 4, so that's really easy. But if we want to do it using our formula that we now have, we'd have to find the tangents at the pole, so we take r equals 0, solve, we get 0 pi 2 pi. The only tangent it has that goes through the pole is is the horizontal axis. Thank you. Sorry. Okay, so we would go from 0 all the way to pi, and that's what happens. You start at 0 here, now you're pi over 6, pi over 2, and by the time you get to pi, you're back there. So it would be 1/2 integral 0 to pi of the square of our r, etc., etc., sine squared. You'd replace 8 squared is 64. Use the TI to graph this function and find the area of its inner loop. I don't know why they're having you use the TI. So they just want the area of this little tiny guy right here. And I'll be honest with you, the difficult part about this is going to be the limits of integration more than anything else. So if you look at what happens, you start here, if you make the table, you start here at 0. By the time you're at pi over 2, you're all the way down here. So what you need to realize is you need this tangent to the curve at the pole and this tangent to the curve at the pole, which is that vertical one is your pi over 2, because that's where you are, but you need to find this one. So you'll find the tangents at the pole, you'll replace theta by 0, which is the same way you're finding out whether or not the pole is on there. And you'll get the sine of theta is 2/3. So that angle theta, that line is theta equals the arc sine of 2/3. Obviously you need a calculator for this one. And I'm going to do 2 because I'm taking this little area right here twice. So 2 times 1/2 integral arc sine 2/3 to pi over 2, and then there's my r squared, and then you'll just enter that on the calculator. You could go from pi over 2, actually you can't. If you wanted this piece here, you would have to go from the inverse sine of 2/3, which is here, to pi minus the inverse sine of 2/3, which is really, really complicated because you can't go from pi over 2 to the inverse sine of 2/3 because that's actually going backwards. So try and find an easy forward straight